Hello everybody, this is the second video in a series of videos about Python programming for engineers. My name is Mark Bakker and I work at the Delft University of Technology. In this video, we will review a few things that went wrong last week and how to resolve them, and we'll learn a couple new things about arrays, lists and tuples. One of the things we learned last week is how to load data. For example, we loaded the data for the temperature in Holland, the average monthly temperature. And we use for that the command the function load text. For example, as follows. We type y1 is equal to load text. And since load text is a function, we open a parenthesis. And I really prefer that you don't put any space between the function name and the parenthesis. And then if you wait a second after you open the parenthesis, the help shows up for the function, if Python knows that it is a function. If no help appears, then you mistype the function or the function doesn't exist. Next we type a quote and we start typing the name of the file we want to load. Python can help you with that. If you type the first couple of letters of the name of the file and then you hit the tab key on your keyboard, I'm doing that right now, then it will show you all the files in the current working directory that start with those letters. In this case, there are two. I select the one I want, Holland temperature.dat. I add a quote to close the text string. I close the parenthesis to close the function. I hit Shift Enter. And I have loaded the Holland temperature in Y1. In fact, I can now print Y1. So remember, load text returns the data and you want to store that data into a variable. You don't want to just print it to the screen. Right now there's only 12 values, but if there is 500, it's going to be a lot of values to echo to the screen. We can plot y1, for example, like that, and then we can add a label. X label, what's along the x-axis is the month. And you get a graph that looks something like this. What several of you try to do is to do x label equal month. And of course you can do that. You get the same graph, but there is no x label at the bottom. And then you realized, oh, so I cannot do x label equals month. I had to do x label, open parenthesis, and then type the label. And now you see something funny. X label now says string object string, and if I start typing here what I want to have along the x-axis, say month, and I close the parenthesis and I do Shift Enter, I get an error message. It says type error, string object is not callable. What is going on? Well, what did you do? You typed here x label is equal to month. That's what we did in the previous try. That means you created a new variable, or you created a variable x label, and the variable is equal to the string month. So the function that was called x label has now disappeared out of Python memory. It only knows now the string x label. And that's not really what you wanted. So how do you resolve that? Well, the only way to resolve it is to restart Python. And to do that, there is here at the top a menu item called kernel. And if you hit kernel and you say restart, it will restart Python and load all the functions it loads when it starts. That just happened. Now if we delete this, we don't want to do this again. We can run these commands again. Everything has disappeared from memory now, so you can go to cell, you say run all, it will run all the cells. It will reload the data into y1, it will plot y1, you see it worked fine, and now x label exists again. If I open the parentheses, it says, it is not a string anymore, it is now the function that it loads at startup, and if I hit the plus here, I get all the functionality of x label. So I can now add month to it and it will work work just fine. We can also add a legend again. Legend. And several of you had trouble with that too. One of the ways to do it is to do legend, and then you have to provide a list of names for all the lines in the graph. In this case, there's only one line, so we make a list. The list is between square brackets, as we will learn again today, and then we, between quotes, we give the name of that line in the legend, and for example, this is temperature. Then we close that list of names, and we close the parenthesis, and we're done. We hit Shift Enter, and the legend shows up. Let's add a second line to that. Let's plot 1, 2, 3, 4 along the x-axis, and 2, 4, 8, and 6 along the y-axis, and make it red. With Shift Enter, you see I added this line to the graph. Now I can add a second legend, and we can just call that garbage. And you see it nicely adds here. There's another way of doing legends that I really like, and that is by specifying a label when you make a plot. What I could also do in this graph, after y1, I can give it the keyword label, label equals. And then whatever the label is of that line, in this case it's temperature. And I can do the same thing for the second line I drew. I say label equals garbage. And now all I have to do is give the legend command. Legend is a function. After every function you have to open a parenthesis, even if you don't want to give it any arguments or any keyword arguments, and you have to close it again. So now I call the legend function. It will automatically go through all the lines in the graph, and if it does have a label associated with it, it will use that label as the legend. So we get the same graph as we had before, but we can also add a keyword here. For example, we can say the location of the legend should be the best location Python can find. We do that and see. It finds out this place is nice, slightly nicer than the upper right hand corner, because it doesn't overlap now with the blue line. Once you are done with your Python notebook, you want to save it. In fact, you want to save it during your work, like I've shown here. It already has a name. This is notebook example.ipynb. So we can do File and Save. Make sure you give it the ipynb extension. I think on Windows it doesn't automatically add an extension to the file if you don't type it yourself. Once you've done that, you want to make sure when you hand in your work that the file runs. To check that, again, you do kernel restart. So it restarts Python. You clear all the cells. Cell all output clear. Now all your output is gone. And then you do again cell run all. It will run all the cells and it will show it works. Why is that important? Well, you may have deleted something out of one of the cells that you need to run another cell. For example, I can delete this entire cell. Well, I cannot actually. Alright, now we go. Run it. So y1 is gone now, but y1 is still in Python memory. So if I run this cell, it still works just fine. But if I say clear all the cells, all output clear, I restart the kernel, and now I run all the cells, cell, run all, I get the error, y1 is not defined. Why is that? Well, now it starts from the top, doesn't have to do anything here. Here it says plot y1. It doesn't know what y1 is because you deleted it out of this cell here. So you should have still add here, y1 is load text, quote, Holland, tab, select the correct one, close the quote, close the parenthesis, run y1. Now y1 is in Python memory. I can run this cell and it works fine. I want to show one last thing from last week, which is the subplot command. The subplot command makes a grid of plots. And the command is subplot, open parenthesis, and then it will, let me look at the help file, the help provided. You can tell it the number of rows in the grid of graphs, the number of columns, and the plot number, where the plots are numbered along the rows from row to row. So if you want to have 2 rows with 2 columns, and we want to have graph 1, and for example in graph 1 we plot 1, 2, 3, so that is a line that goes from 1 to 2 to 3 in both x and y, we get this graph. Then we add to that, we say again subplot, 2 rows, 2 columns, and we want to take graph 2, and we want to plot along that graph, for example, y is 2, 4, 2. Let's do shift enter, see what that looks like. See, now it has plotted, this is graph 1, this is graph 2, and if we now do graph 3, that will appear in the lower left hand corner, and graph 4 will go here. So we can do a subplot, 2 rows, 2 columns, graph 3, and for that let's just put text in that graph at x is 0.5, y is 0.5, and say the text is hello. There is graph 3, which has at 0.5 the word hello, 0.5 being the lower left hand corner of hello. And then we add the 4th graph, subplot, still 2 rows, 2 columns, graph number 4, which will be this one. And for that we're going to plot a cosine function, for example. So we have the cosine of the angle going linear spaced from 0 to 10 times pi with 100 steps. And one more parenthesis should do it. And there we go. Now when you see this graph, you may not like the space between the columns of graphs or between the rows of graphs. And for that there is a separate command called subplots with an S underscore adjust. And when you open the parenthesis, there's a number of things you can give it. And the 2 keywords that are most useful are the width space, that's the space between the columns, and the height space, the H space, which is the space between the rows. So if we tell, for example, that the W space should be 0.5 and the width space and the height space should also be 0.5, then you see the space between the rows and the columns has increased to the value you gave it. Alright, let's move on to the new stuff. We're going to learn this week about arrays. We already used arrays a little bit last week, but we're going to learn a lot more this week. We can create an array, for example, with the array command. X is equal to array, and if we want to make a one-dimensional array, so one row of numbers, then we give it a row between square brackets, and for example with the numbers 1, 5, 3, 2, 7, 8, 6, 4, 2, 9. How many do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more, about 8. Print X. Oh, and I got an error. See, they should be separated by commas. I didn't tell you that yet. And if you don't do that, you get an error message. Here they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And we've already learned you can do math with arrays. You can say print x plus x. That will add every item in the array to itself. So it will do a term by term addition. You can do print x times x. If you do x times x, it will multiply every item in the array by itself. But you can also, for example, do the cosine of x. Then we'll take the cosine of every item in the array, and it will assume that the value in the array is in radians. We want to print that too. And you see that works. The first one is is x plus x, so that should be 1, 10, 4, that's correct. The second one is x times x, that should be 1, 25, 4, that was correct as well. And the cosine of x, I don't know that out of the top of my head, so I cannot tell. You can access the individual items or a range of values inside an array by given the index. The very first value in the array has index 0, and that requires a little bit getting used to. When you specify the index of the array, you use square brackets, as I'm showing you here. And it's important to realize why that is. If you have a function, like we used earlier today, then you use round brackets, called parentheses. And if you give the index of an array, you use square brackets, the ones I'm showing you now. And x0 is the first value in the array. So if I say print x0, then I will get 1, which is indeed the first value in the array. If I say print x1, that is the value with index 1, which is the second one, which is the number 5. And indeed that is correct. You can also print or use a range of values. For example, you can say I want to have the first 5, so I go for x from 0 to 5, and that will give you the values with index 0, 1, 2, 3, 4, and it stops at 4 because it will not include 5. Right? So the last value you give is not included in that range. Let's see if that's correct. You get 1, 5, 2, 7, and 8, and that's number 0, 1, 2, 3, and 4. Of course, you don't have to start at 0. You can also do print x from number 3 to number 5. Right? That gives you two values, the one with index 3 and the one with index 4, because 5, it stops at 5. As you can see here. What you also want to know often is the length of the array. Of course, there is a command for that. It's called len x. The length of x is 10. It has 10 values. And if you want to access the very last value in the array, you could type x, the length of x, but that would be with index number 10. That doesn't exist. So if I do that, I get index 10 is out of bounds for x is 0 with size 10, because there's only 10 values. The last value in the array will have index 9. So to access that one, you would have to type the length of x minus 1. And just to make sure we remember again what we have, say we print here again, x has the values x, because I forgot what we had, it's off the screen right now. And we can now print the last value of x. X has these values, and indeed when we print the last value of x with the command x, len of x minus 1, you get the correct value. That is of course a little bit inconvenient to have to type len of x all the time, so there's a shortcut. You can simply type x with index minus 1. And index minus 1 means the length of x minus 1, so it's the last value. So, and it works the same way with minus 2. That is the length of x minus 2. So in this case, that should be the second to the last one, which is number 9. See, that works indeed. If you do print x minus 2, you get number 9. Every array also has a dimension. For that, there is the command. To find out what the dimension is, you have to command ndim for a number of dimensions. Ndim, open parenthesis, and it asks you for the array you want to find the dimension about. If you print that to the screen, you get the dimension of x is 1. It has one dimension. It only has one row. But you can also create arrays with multiple dimensions, and we will make frequent use of arrays with 2 dimensions. Let's create one, but we'll start with an array that is dimension 1. For example, x is equal to a range 15, and we say print x. You'll see a range 15 gives you the numbers from 0 to 14, not including 15, but that is 15 numbers. And we can resize this array. x is equal to resize, the command resize, and the resize asks you for an array that you want to resize, the new shape, and it return that, and we'll store that again in the array x. So we give it x, and we want to make a new size, and the new size is 3 rows and 5 columns. Notice those are given between parentheses. If you now print x, you see it has 3 rows and 5 columns. If you print the dimension of x, print ndim of x, you see it has dimension 2. It has rows and columns. And you can also print the shape of x, and it will tell you it has 3 rows and 5 columns. There are many ways of creating arrays. We used here the arange command, and earlier in the notebook we used the array command. There's also one that's called zeros, and there's one that's called ones. X is zeros, creates an array with zeros, and you can give it the shape. As you see here, the shape, and we say we want to have 5 rows and 8 columns. Notice the shape is given between parentheses. This can be as many dimensions as you want. It can have 5 rows, 8 columns, and then another dimension, 10 of the third dimension and 15 of the next dimension, if you wish. Print x, you see we have 5 rows, 8 columns, all filled with zeros. We can now assign values to part of the array. For example, to give another value to row 0, we say x0 is equal to 8. And you see that has changed all the values in the first row to 8. We can also give new values to a column. For example, x. If we type a colon, we mean all the in that dimension, in this case all the rows, colon, comma, and then column 3 with index 3 is equal to 25. And then you see this is all rows and column with index 3, 0, 1, 2. This is index 3, indeed all turn to 25. You can even do a block. If you say x, row 0 through 3, so that is 0, 1, and 2, and then columns 5 through 8, and we assign that the value 600, then you see indeed here rows 0, 1, and 2, not including 3, and columns 5, 6, 7, not including 8, 8 doesn't even exist, has gotten the value of 600. You could even have given an array here. You could have said this is 600 times an array of ones, of in this case 3 by 3. That does the same thing. But if you do that incorrect and you give an array here that's not the same shape as the block in the array you assigned here, for example, if you say this is equal to 4 rows and 3 columns of 600 values, which doesn't fit in this part of the array, then you get a nice error message to tell you could not broadcast input array from shape 4.3, which is this array, into the shape 3.3, which is the block you assigned here. So you have to make sure that if you assign arrays to each other, they have the same shape, else Python doesn't know what to do. That's all I got for you today. I hope you enjoyed it and hope to see you next time. Goodbye.